All right, guys, so here we go. I have my calculator, and what I'm going to do is I'm just going to type this equation in because I'm pretty sure I'm going to need it, right? So type it into your y1. So I'm going to push alpha y equals. I want to get the fraction thing there. I guess I don't need it immediately. 44, open parenthesis. I guess I'll delete that. Alpha y equals. And sorry, guys, that I'm going slow. It's just that using this little mouse here, it takes forever. And let me close that, put a third power. So far, so good. I don't see any mistakes so far. Open parenthesis, alpha y equals, enter. If you want it to look like that, you know. 1 minus, and then x over, looks like a 300. And then scroll to the right, close it, and then put the power 7. So there it is. I don't see any mistakes. Bam. There's my R of T. Yeah, everything looks good. Let me go to my home screen and let's read this together, guys. So let's see what they want. And let me move this down. All right, so I have people enter a line for an escalator. Does everyone know what an escalator is? Has everyone? Okay. At a rate modeled by the function r given by, and they give you this function. And there's a typo that I see, guys, right there. It says where R of T is measured in people per second, and then where it says at, that should say and. So let me fix it right now. That should say and. And T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 persons per second. Okay, so this is the out. Come on, come on. There are 20 people in line at T equals 0. Okay, so read that, soak it in real quick. I'll be right back. Give me like a couple minutes.
All right, sounds good. Thank you so much.
All right, guys, do we understand what's going on right now with this right here? All right, letter A. How many people enter the line for the escalator during the time interval 0 to 300? Well, it tells me up here, number 1, people enter a line, and this is the rate that it's modeled by people per second. So think about it. If I want to know how many people enter, people per second times second is people. So all I got to do is find area under the curve of which one? Of that one. So letter A, I hope did everyone do this? 0 to 300 of R of T. Do we have any questions with that? Like, if you did not do this, did you guys need any hints, or like, do you guys need advice on how to figure out that it was this that they wanted? What I would always do, guys, is just use the units. R of T is people per second. The DT, remember, this means area under the curve. The DT is seconds. People per seconds times seconds is people. So this means people. So there it is. I'm going to take out my calculator. So here's my calculator. I'm going to push math. I'm going to push what number is it? 8 or 9? 9. And then I'm going to go 0, 300. And then I just type in Y1, alpha trace, Y1. And I think they said to the nearest whole number, right? Or something. Oh, actually, no, they got a perfect 270. All right, so there it is, a perfect 270. And if you want to write a sentence, there are 270 people that enter the line for the escalator between time T equals 0 and time T equals 300. Done. All right. Any questions on that one, guys? All right, let's see what it wants for letter B. Let's see if it gets harder. During the time interval 0 to 300, there are always people in line. Always. For the escalator. How many people are in line at T equals 300? Okay. How many people are so they want to know how many people are in the line, not how many. So that means it's easy. Watch. Initially, how many people are there? 20. And then I got to add the people that have gone in line. So really, it's like adding this, the 270. And I got to subtract the people who have left the line. Does that make sense to everyone? So I would do it like this. Number of people in line. I like equations, so I would do it like this. Equals the initial amount plus the amount of people that have gone into the line. So that's 0 to 300 of ROT, which we already did, minus the amount of people that go out of the line. And that is a nice linear number. Remember right here, we got it. Let me go underline it in blue. As people get on the escalator, they exit the line at a constant rate of 0.7 persons per second. So I'm leaving at 0.7. This is a nice linear constant. And if I want to know it at 300, I put a 300 there. And I guess I should be more specific. Number of people in line at t equals 300. So there it is. So let me take my calculator. 20 plus 270 minus 0.7 times 300. There's 80 people in line. There is 80 people in line at t equals 300 seconds. There's another way to do it, guys. I'm not a big fan. And the reason why I'm telling you this is because I remember looking at the rubric and they did it differently. Do you see how I wrote right here 0 to 300 ROT dt? The rubric, I think, has 0 to 300 ROT minus 0.7 because ROT is the rate going in and 0.7 is the rate going out. It would work. I just don't like it. Look, 20 plus, and then math, 9, 0, 300, and then the rate in, alpha trace y1 minus the rate out, which is a constant 0.7, and it works. You'll get the 80, watch. See, it works. You get the 80. I'm not a big fan of that one. I'm surprised that it had that one right off the bat. Why do I not like that one? It's still calculus. You're still fine, but I don't like it because 0.7 persons per second, that's a constant, and I'm always leaving it at that rate. And anytime I see algebra, I just say, oh, it's just algebra, and I like to pull it to the side. Does that make sense, guys? So if you want to do it the calculus way, this way, go ahead. It looks fancier. I did it. This is the only calculus right here. And then that's just the algebra part, 0.7 times 300. That's the rate at the constant rate that they go out. So there it is, guys. We got the answer. We're good. All right, let's see what it says. Are we okay so far? All right, now it says, for t greater than 300, what is the first time t that there are no people in line for the escalator? Okay, that's assuming that there's no more people that enter the escalator after 300 seconds, which according to this, check it out, they covered all the holes. At 0, for t greater than 300, there are no more people coming into the escalator or into the line. Does that make sense, guys? So all we got to do is worry about these 80 people here. So I know that the rate going out is 0.7 people per second. Let the units help you out. So how much time? So, okay, let me slow down, guys. What is the first time t that there are no people in line? Well, how long does it take for these 80 people to exit? That's what I want to know. So let the units help you out. 80. Let me see. How do I want to do it? I want time. Okay, I'm trying to see how I can. Let me see if you guys understand this. 80 people divided by 0.7 people per second. What's up? Oh, you need an outlet? There's an outlet there on the side. You're just gonna have to move the chairs. Do you see them?
Oh, no, it's fine. I need to talk to you.
Oh, okay. Sorry, miss. This is gonna give you seconds, but I don't know if you guys can see it. Can you guys see that gives you seconds? Okay. If you don't see that gives you seconds, you can always do a T-chart. Chavez, what do you mean a t-chart? 0.7 people per second. So I would put 0.7 people per 1 second. And I have 80 people, so that's what I want to cancel. And look, there's my t-chart. People cancel out. 80 divided by 0.7, and you get seconds. Do you guys see how that works? Okay, so it doesn't matter how you see it. So 80 divided by 0.7, and that's only going to tell you how many seconds after 300. So don't get tricked, guys. 80 divided by 0.7. So that's 114.285 seconds after 300. 114.285 or 286. 114.286. That is not the time, guys. Look. Yeah, well, I guess you got to be careful how you say it. If you say it correctly, I think you'll still be right. If you say 114.28 seconds after t equals 300 is when there's no more people in the escalator, I think that would be correct. But what is the number one way to be 100% sure that you won't get it wrong? Add 300 to that. Plus 300. So at 414.286, there are no more people in the line. At t equals 4, and I already forgot the number, guys. 414.286. So I guess just add 3 to that, right? 3 plus 1 is 4. 414.286 seconds. There are no more people in line. Sorry, guys. I'm writing kind of weird because I'm writing like that on a tablet. If you use proper English, you'll get it right no matter what. So if you use the 114.286, make sure that you got a reference at 300, right? 114.286 seconds after t equals 300. But this is guaranteed, the 414.286. All right, how do we feel so far? All right, last one. For 0 less than t less than 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time, justify your answer. Okay, so here we go. What I would do right off the bat, I would do a table. T and then number of people. I do not know how many I need because I know that I have a min. I know at 0 I have 20 people. And I'm gonna say right there, and I know that at 300 I have 80 people. Those are already calculated. We already did those. We need critical numbers. So we got to think. My net rate is, what is my net rate? Is this guy, R of t, minus 0.7. The ROT is the rate going in. The 0.7 is the rate going out. Do you guys agree? This is what I'm going to try to find. Well, okay, that's not what I'm trying to find. I'm trying to find a max or min for the number of people. All right, let me get an equation for the number of people. We do need that equation that I just wrote there, by the way, guys. Let this help us out. Wherever there's a time, put a t there instead. And wherever that's 300, put a t there. So my equation is this equation. Number of people is 20 plus integral from 0 to t of r of t minus 0.7t. Okay. Are you guys okay so far? This equation is what I want to find a max or a min of. Anytime you want to find a max or a min, you got to find, there's something called critical numbers. Do you guys remember that? To get a critical number, I got to take a what?
Derivative.
Derivative. And I can take a derivative of this, really simple. And look, check it out. So here's my derivative. I'm just going to put hashtag with a derivative on it. I would not write it like that on the AP exam. I would write like derivative or something like that, or net rate. And check it out. We get our equation that we had a little while ago, ROT minus 0.7. And notice that I'm going to equal this to 0. Do you guys see that? So here we go. I'm going to take my calculator. So here's my calculator. And I already have ROT and Y1. So I'm going to turn off Y1. I'm going to go to Y2. And I'm going to go alpha trace Y1. I'm going to go minus, and I'm going to leave Y1 alone because I might need it in a little bit, right? Minus 0.7. And then all I care about is where it crosses the x-axis. So I'm going to go to window, x-min 0, x-max 300.
Wait,
and
how
you
do
just
turn off an equation?
Oh, okay. Go back to y equals. Hover over the equal sign and push enter. And then it should be off now. Do you see that? Okay. So here we go, guys. I'm on window 0, 300, X scale. Make it like a big number, like 50 or 20. That way you don't see a whole bunch of little thingies on it. You want to hover around the x-axis, guys. So maybe -1 or -2 to 2. -2. I'm going to go -2. I don't know how this graph is going to look. I really don't. And let's push graph and let's see how it looks. Bam. 1. Bam. 2. Do I have any more? All right. This is my derivative graph. And remember, they want, what did they want? A minimum? So this one, can you guys see my cursor, the arrow? I have two critical numbers. I got this one and I got that one on the furthest right. Do I have to worry about the one on the right? No, because the one on the right is a maximum. It's going from positive to negative. Does that make sense, guys? You still want to state it in there because it might be a point, but you don't have to calculate it. So here we go. I'm going to go second calculate 0, because that's what we're doing. We're calculating a 0. And then okay, let me go get the right one first. Left bound, and I'm only getting the right one because it was already over there. Right bound, enter, and it looks like 166.5742. So I'm gonna cut this into 2, 166.5742, and I'll put not applicable. This is a max. This is max, or local max, if you want to be specific, because we don't know if the 80 is a bigger one. This is a local max. All right, let's find the other one, guys. Second, calculate 0, and it says between what? You can actually push the number. I'm going to push 0 in here. 0, enter, and then right bound. I don't know what that is, so I'm just going to use my cursor. Right bound, so 40-something, enter. Guess, nah. Bam, 33.0132. So that one I want to save. 33.013298. 33.013298. 33.013298. Store that, guys. So here I am storing it. Second quit, X, enter. I'm going to store that to A. So there it is. And maybe if you want to note it somewhere that you're storing so I'm going to say T equals 33.013298. Store that to A. And then I would put the other one in here, but we're not storing that one to anything. Okay, let's find out how many people. I come back here and I'm going to use my equation. So if you want to say, I don't know, maybe say people and maybe use parentheses. So maybe put people like that. That's your function. People at A, and now they know that I'm talking about this, equals, and let's see what I get. So let's see. So I'm going to push, you know what? I remember doing it earlier. I have it up here somewhere. Look, that one right there. Enter, and I'm going to change the 300 to A. Delete, delete, delete. Alpha A. Enter. And there it is, 3.8034. It wants you to round, so we'll make a statement in a little bit. 8034. Round to the nearest whole number. All right. Should we say 3 people or should we say 4 people? 4? Okay. By the way, they actually also took 3, because can you have 3.8 of a person? When it comes to populations, usually you round them down. So because you can't have 0.8 of a human, because that's just unethical to have 0.8 people. I'm trying to make a joke, guys, but it was not very funny. All right, I'm going to say there are, and this is, try not to write it as bad as I'm writing it, guys. There are 4 people at, to the nearest one, I'll find the number of the line, justify your answer. There are 4 people at t equals 33.013298. Did they give me times, seconds or something? All right, let's see how we did, guys. Should we look at the rubric? Let's look at the rubric. So here we go. And then 2000 College Board. Here we go. Can you guys see my screen here or no? All right, so let's see. Letter A, they give us 2 points. I'm surprised, guys. Usually they only give you 1 point for that, but they give us 2 points for the integral, 0 to 300 RTDT, and then the answer. And they wrote a nice little sentence. I think I would prefer that you guys write a sentence. According to the model, 270 people enter the line for the escalator during the time interval 0 to 300. Perfect. Number 2. So remember I told you guys that I saw a sneak peek. I don't actually like this one. I actually prefer 20 plus 0 to 300 RT dt minus 0.7 times 300, but that's fine. No big deal. There it is. They got 80 people, and then they just wrote one real quick sentence. 80 people are in line at time t equals 300, and there it is, 2 points. Letter C. Based on part B, 300 is 80. The first time t is that there are no people in line. And I like it. 300 plus 80 divided by 0.7. Yeah, I like it. I like that. Letter D. The total number of people in line between 0 and 300 is modeled by. There's my model. I like it, guys. I like it a lot. Look, now they're doing the algebra, the 0.7t. Over here, they didn't. They're funny. And they got 2 values. RT minus 0.7 is 0 at 33.0132, just like we did, 166.5747. Notice that they calculated the T2. You do not have to. If you want to, go ahead. But I would just write, it's a max, so why waste time? So I would not do it. And there it is. The number of people in line is a minimum. Oh, I didn't even say minimum, right? I should have said that. The number of people in line is a minimum at time t equals 33.013 seconds when there are 4 people in line. And that's it. So let me come back. So it says a particle moves along. Oh, by the way, these are all questions from the 2018 free response exam, guys. A particle moves along the x-axis with velocity given by, and they give you this velocity. I would type this into your calculator. Everyone now has a TI-84. So I would type this into your Y1. And it's between 0 and 3.5. The particle is at position x equals -5 at t equals 0. So this is your initial position. So I would write it somewhere. And then, so here we go. Let me take out my calculator, guys. Excuse me. So take out the calculator. Sorry, guys. I should have had it taken out already. My apologies. And let me share that Zoom with you guys. Okay, so there's my calculator right here. And I'm going to type that in, guys. So first, I'm going to check my mode. It's in radian mode. Good. Always have it in radian mode, guys, no matter what. So here we go. Y1, I'm going to go alpha y equals to get the little fraction thingy. And I'm going to type that in. 10 sine 0.4 x squared close 10 sine 0.4 x squared. That's correct. And on the bottom, I'll put x squared minus x plus 3. I don't see any mistakes. I think I'm good. Second quit. All right. Letter A. Find the acceleration of the particle at t equals 3. I think I remember grading this question when I was a reader that year. So you just have to show that you know how to get acceleration from velocity, guys. So you needed to show this one little step. You just needed to show a of 3 is equal to v prime of 3. And that's all they wanted to see there. And then just give me the number. So you already have it. Let me take out the calculator. It's already on my y1. So I'm going to go math. And then I'm going to go derivative. So number 8. And then I'm going to type an x there. I'm going to go alpha trace y1. And I'm going to go at x equals 3. And I'm push enter. And there it is. Negative 2.118. Negative 2.118. If there's units, you put units. They didn't give me any units here. They just told me that's velocity. And the time is between 0 and 3.5. Position is that. They didn't give me any units. So there you go. There it is. That's it. Can we do that for letter A, guys? Awesome. Letter B. Find the position of the particle at t equals 3. So hopefully by now, this is becoming automatic for you guys. If you guys have been doing the delta, I think this is becoming a super automatic to you guys because it is a common question all the time. So the position at 3. My position at 3 is my initial position given plus the displacement from 0 to 3. And I get displacement by integrating velocity. So there it is. I have my initial position. The initial position was negative 5. So I'm just going to go negative 5 plus, I don't know what that is. That is some number. You know what? I'm just going to rewrite the integral again because I'm just going to type the answer. And here we go. I take my little calculator out again. And I'm going to go negative 5 plus math 9, 0 to 3. And then I go in there and I go alpha trace y1, and then I put an x, and then enter. And there it is, negative 1.760. So x of 3 is negative 1.760. They didn't put any units. If you want to put a unit, just put the word unit in there. But I wouldn't. I would leave it alone. And there it is, guys. That's it. You're done with letter B. All right. Do we have any questions on letter B, guys? All right. We're boss. We're turning into bosses. Letter C. Evaluate the integral between 0 and 3.5 of v of t and 0 to 3.5 of the absolute value of v of t. Interpret the meaning of the integral in the context of the problem. Okay, let's do that, guys. So I'm going to go ahead and first do this. 0 to 3.5 v of t is the displacement of the particle from t equals 0 to t equals 3.5. And that's it. Well, that's it for that one. Integral from 0 to 3.5 of absolute value of v of t dt is, what is this?
Distance.
Perfect. It's a distance. It's distance. And make sure you tell me, tell me the distance. Make sure to tell me that you write your time interval. V of t is the distance of the particle. Is the distance traveled by the particle. Is the distance traveled by the particle from t equals 0 to t equals 3.5. You could have probably just written it in interval notation, t between 0 and 3.5, but I went ahead and wrote it. And then I'm just going to give the values. Interpret the meaning of original context. Evaluate, okay, because it wants the value, 0 to 3.5. And I think maybe there's better answers. Maybe I find this and write like whatever the number is and then write the displacement. All right, so let's see what that is. Alpha, nope, not alpha yet. Math 9, alpha trace, oh, I'm all over the place. 0, 3, oh, 3.5, 3.5. And alpha trace y1. And then push enter. 2.844. You can also say 843. We'll look at the rubric in a little bit. 2.844. Now let's look at this. And I kind of don't like my answer, guys. Let me tell you why. I think there's a better way to write it. 0, 3.5. Absolute value. So push math, number, enter. And there it is. There's the absolute value, guys. Alpha trace, Y1. And then enter. And there we go. Oh, it's thinking, but it'll work right now. It's working really hard. 3.737. It's working really hard to provide. So there it is, guys. I'm not thrilled with the answer that I wrote. I think because it tells me evaluate, I think that I probably should have done this first. And then I should have written integral from 0 to 3.5 v of t dt equals 2.844, which is the displacement of the particle from t equals 0 to t equals 3.5. And then integral from 0 to 3.5 of absolute value of v of t dt equals 3.737, which is the distance traveled by the particle from t equals 0 to t equals 3.5. Does that make sense, what I'm trying to tell you guys? Because I don't like my answer. I think I would have written it different. I think I would have written this first, and then I would have put those numbers in my sentence. Because the top just kind of sounds just like a definition. So I think I still would have gotten the credit, but if you want to be 100%, I would include those numbers in those sentences somewhere. Are we pretty clear, guys? Okay, let's keep going. A second particle moves along the x-axis with position, sorry guys, with position given blah, between 0 and 3.5. At what time are the two particles moving with the same velocity? Okay, perfect. I already have the velocity in y1. All I got to do is find this velocity. Notice it has a subscript of 2, so let's keep that subscript, guys, so people know, so they know. So what I would do is this. I would write v of 2 of t is equal to x prime 2 of t, so they know that I took the derivative, and that equals 2t minus 1. And I'm going to equal that to the velocity. So I'm going to go 2t minus 1 equals, and I already forgot what the velocity was. You can probably write v of t and be fine with it, but I'm going to write that expression. 10 sine 0.42 t squared. 10 sine 0.4 t squared over, and let me minimize this guy so I can see, t squared minus t plus 3. Do I gotta show them any algebra here, guys? It's a calculator question. No, you do not have to show them any algebra. You're already telling them that you're equaling the equations together, and from there you can just go right to writing the answer. T equals something. I don't know what that answer is. So I'm gonna go to y2. So here's my calculator. I'm gonna go to y2, or y equals. And on y2, I'm gonna type in 2x minus 1. I wanna know where they intersect. So I click on window, and you only care between 0 and 3.5. 0, 3.5. Chavez, how do I tell what to make the y values? Let this one help you out. At 0, that's -1. So I'm going to put -1 for y min. And then at 3.5, let's just round to 4. 2 times 4 is 8. 8 minus 1 is 7. So I'm just going to go to 7. Do you guys see how I got the y values? Okay, and then I'm just going to push graph. There's y1. There's y2. I want a better graph, so I'm gonna cut my y value in half. I'm gonna go to like 2. 1, 2, 3, 3.5. I know if you're stuck for time, you probably don't have time to be doing all this, but I want a better graph. And since I feel like I'm going at a pretty fast speed, there it is. That's the t value I want. I tell the calculator to give me that answer. Second, calculate number 5. I only have 2 equations in there, guys. Enter, enter, guess. Now there's only one intersection. And there it is, 1.57054. 1.57054. 1.57054. And notice that I haven't been writing any sentences. I probably should. It says at what time t are the two particles moving with the same velocity? I should probably say at time equals 1.57054, both particles are moving at the same velocity. But it's okay. I'm in a hurry, and this would be full credit. So let's see how we did. Let's look at the rubric. Is this a rubric right here? This one. I was looking at it earlier, guys. All right. So look at that. V prime of 3 equals negative 2.118. We showed that. We said A of 3 equals V prime of 3. And I think we got that answer correct. Did we get that answer correct, guys? Okay. And then your position was your initial position plus the displacement. There it is. And I think we got negative 1.760. I think we got it right also. Correct? Okay. And then they wrote a little sentence. I think we should start in a habit to try to get there. So look, here's what I was trying to say. They evaluated it first, 2.844 or 2.843, 3.737. The integral is a displacement of the particle over the time interval. Oh, look, they're lame. They didn't even put the value. I wanted to put the value in there, but that's fine. It looks like they just did the same thing. They wrote the interval notation for the time. I think I kind of like that better than what I did, but that's fine. I think we got full credit. All right, let's keep going. And perfect. V of t equals x of 2 prime, x prime of subscript 2t. I think you can do that, but I wanted to put the whole equation in there. So there it is. So I put the whole equation, 1.570, perfect, and then they wrote a little sentence. So we got all 9 points, guys. Are we starting to see that these aren't that bad? Like, they're pretty easy. They're not that bad, right? All right.
These ones are, but the ones on the exams are hard.
Oh, so, but this was from the exam. This is from the 2018 exam.
Well, yeah, it was a good. Very cute.
Okay, don't worry, miss. We're going to be doing more. We're going to be doing a whole bunch more. We're going to start having optional tutoring. I'll tell you guys when. All right, this is the one that I wanted to go over. The one that I wanted to definitely hit up. We have linear lines, we have segments, we have a parabola, and yeah, this is what we need more practice on. So let's see. This is no calculator. This is question 3.
But this one, could we get?
You want a head start?
Yeah, could we get the 15 minutes?
How about 10?
Oh, okay. Yeah, that
Well,
works.
we can do 15, but I'm just scared that what if people are just looking at it? You know what I mean? All right. So I'm going to give you a 10-minute head start. And if you are really good, like let's say you are still going at it, then keep going at it, guys, because I think you'll be good. So I'm going to go ahead and give you 12 minutes. So here it is. I put the timer at 12 minutes. Ready, set, go. All right, guys, I'm going to go ahead and start it. It's the countdown's at 3 minutes, but if you feel like you're still going strong, keep going. You probably got the first half correct. So here we go. It says the graph of the continuous function g, the derivative of function f. Ooh, that's a big. The graph of the continuous function g, the derivative of function f, is shown above. So what does that mean? That means that that's f prime. That's what that means, guys. The first thing I would do is put g equals f prime. So you have the derivative graph. The function g is a piecewise linear function between -5 and 3. Okay, I can see that. And g of x is a parabola between 3 and 6. If f of 1 equals 3, what is the value of f of -5? Okay, here we go. Consider this like position. Consider velocity, or consider f prime like velocity. So this is like saying position of -5. My position of -5 is equal to the position they give you initially, f of 1, plus the displacement. The displacement is going to be from 1 all the way to -5 of f prime. There it is. If you can do that, you're winning. Would I reverse that? I think I would probably leave it alone. No. Okay. I'm going to let you guys decide. Are you guys tempted to change that plus to a minus and switch the -5 to the bottom and the 1 to the top? You guys want me to do that? What do you guys think? Did you do that, Mazuka? Or you left it like this? No, it's okay. Say it.
Oh, sorry. I heard someone eating. I left it like that, but I don't know if I messed it up because of that. But
Yeah, you can leave it. You can leave it like that. Okay, let's leave it like that then. F of 1 is 3. Well, it wants a value, right? Like, don't just leave it like that. Get the actual value. 3, and then I'm going to figure out what this is right here. So let's see. This right here at 1, that's just a triangle. 1 times 2 is 2, but half of 2 is 1. So that's 1. And then -5 all the way. That's a trapezoid. You can either do a square and a triangle or just do a trapezoid. So let's see. Base 1 is 1, 2, 3, 4. So 4 plus base 2 is 1, 2, 3 times my height, which is 1, 2, 3 divided by 2. 4, 5, 6, 7. 7 times 3, 7, 14, 21. 21 over 2. Now it's below the x-axis, so it's a negative. Now look how I'm counting. I'm counting backwards, so it's going to be a positive. I hope that doesn't confuse anyone. Since you're counting backwards, whatever is positive is negative, whatever is negative is positive. So 3 plus -1 plus 21 over 2. And you can actually leave it like that, guys. I wouldn't, but you can actually leave it like that. 3 plus a -1, 2 plus 21 over 2. So 2 times 2 is 4. So 4 over 2 plus 21 over 2. 21, 25 over 2. I don't think I made any mistakes. Let me just make sure. No, I think we're good, guys. Going backwards, -1, positive. Yeah, I think we're good. There it is, 25 over 2. If you are not confident in yourself, you can leave it alone right here. Sorry, I saw my phone flash, and I had to look down real quick. I hate that I'm a slave to my phone, guys. Sometimes I want to just throw it away. Okay, sorry. Sorry, guys. Do you guys ever feel that way with your phones or no? Never? Okay. Okay, I know you guys have probably already know about this. I'm doing a better job of replying to text messages, but I used to be really bad, like really bad. I wouldn't reply to text messages till like a week later. And then by then, or okay, maybe I'm exaggerating. Maybe not a week later, but 2 days later, 3 days later. All right, I think that's it for letter A. Letter B. Evaluate 1 to 6 of g prime of x dx. Okay, how am I going to do that? La 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 la. Oh, dummy, that's g right here. I don't know why that took me such a long time to figure out, guys. So here we go. We're just going to integrate. We're just going to find the area under the curve between 1 and 6. So that's all we're doing here. So sorry that it took me a while to look at that. So 1 and 6. So I'm going to go from here all the way to here. Ooh, okay. They actually want to see you integrate. Wow, I wasn't expecting that. Okay, I'm going to break this up. I'm going to go from 1 to 3. That's just geometry. And then we're going to go from 3 to 6. This is just geometry right here, this one. I'm going to put geometry there. But this, they actually want to see you do that, the antiderivative of that. I do remember some students doing a shift, like they shifted that to the origin because it's just a parabola, 2x squared. And they just did 2x squared from 0 to 3 or something like that. I forget how they did it, or from negative, they did it from -1 to -1 to 2. I think that's what they did, which is fine. You can do that, but I would just leave it like this. So here we go, guys. That square is 4. Let me know if I make mistakes, because I make mistakes all the time. And I'm integrating from 3 to 6 of 2 parentheses x minus 4 close it squared dx. I don't think you need to expand this one. If you have a linear expression, you can only do this if it's a linear expression. I think we've mentioned it in the past, but just in case. If you have a linear expression on the inside, you can just pretend like that's a whole, pretend like that's like a u or something. So here we go, antiderivative. 4 plus, and then bracket, and then 2 parentheses x minus 4 to the third power divided by 3, and lower limit 3, upper limit 6. Excuse me. And now I'm just going to do upper minus lower, guys. 4 plus 2 parentheses 6 minus 4 close it cubed over 3 minus 2 parentheses 3 minus 4 close it cubed over 3. If you are scared, you can leave it alone right here. But you're not scared, right? We're not scared. All right, guys. Sorry, I need to have some fun, right? We're not scared. 6 minus 4 is 2. 2 cubed is 8. 8 times 2 is 16. 16 over 3 minus negative 1 cubed is negative 1. Negative 1 times 2 is negative 2 minus a negative 2/3. So 16, 17, 18. So let's see, 18 over 3. Does 3 go into 18? Yeah, it does. 6 times, right? So I got a 10. So I don't know. Hopefully I'm right. I haven't looked at the rubric, guys. I mean, I did. I looked at it, but I haven't looked at it like very detailed to see if I'm getting the correct answers or not. So I got a 10, just a flat 10. We'll check in a little bit to see if we're right. Let's see. Between negative 5 and 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Okay. This is just for notes. I would not write this on the actual exam. This is just for notes. So just write this for notes. F is increasing when f prime is positive, because f prime is slopes. F is concave up when f prime is increasing. This is just for you guys, 2 bullets. I currently have the graph of f prime. So that is the best graph to use. And I can tell you guys I can see that you guys are getting tired. So we'll stop after this, guys, because we don't want to push it when we start doing more. And if we do more when we're tired, we're not going to get anything in there. So here we go. Where is f both increasing and concave up? So I'm looking for this. I'm looking for f prime to be positive, and I have the graph of f prime. So I'm looking for where f prime is above the x-axis and where f prime is increasing. So let's look for that. Where is f prime positive and increasing? Let me go ahead and do it in blue here. Blue. No, that's blue. Right here. And right there. So here's what I'm going to write. I'm going to write F is both increasing and concave up on the intervals. And I think we said 0 to 1. And then we said 4 to 6. Since these are the only intervals in which f prime is positive and increasing. And if you want to write a little sentence meaning that f is concave up and increasing, then you can, but I would just leave it like that. F is positive and increasing. Perfect. I think that's perfect right there, guys. How are we feeling? We feeling okay? All right, let's see what we have left. Find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Again, it all has to do with this second bullet right No. What kind of? Remember that you have a point of inflection when you change concavity, concave up to concave down, or concave down to concave up. So I am looking for where f prime changes from increasing to decreasing or vice versa. And I remember there was a whole bunch of commotion here. Okay, let's look at it. I'm going to outline it with red. So I'm going, it's flat, it's 0, and then all of a sudden I have a jerk here, or an abrupt change, and I'm going up. Is that a point of inflection on f? Did it change from increasing to decreasing? No, it did not. I can see some of you like, I don't know, Chavez. This is not increasing or decreasing between -5 and -2. That's just the slope of 0, guys. I'm not doing anything. Then I'm increasing, okay. Oh, what about here? Do I have a point of inflection there? No. If you really want to think about it, guys, these are all linear lines. These my slopes. Think about it. There's f prime. So that means f is a constant -3. That means I just have linear lines. There is no concavity on linear lines. Does that make sense to you guys? All you have going on is like -3, and then I'm increasing again, or I guess concave up, or no, decreasing, but okay, you guys know what I mean. All right, here we go. Now here comes the beautiful part. Increasing, okay, nothing yet. Decreasing, this is f prime, so that means I'm concave down. Then the 0 at 4, your f prime is 0, and then after that your f prime is positive. So there it is. I just have 1 at x equals what? 4. And you got to give a reason. Graph of f as a point of inflection. Inflection at x equals 4, since this is the only location where f prime is changing from decreasing to increasing at x equals 4. You can probably also say f prime prime changes from negative to positive, but I think this is the best answer. All right, let's look at our rubric and see how we did. So our rubric, question 3. Why is it moving so slow? All right, did we get 25/2 for letter A? All right, perfect. Look what they did. Actually, no, yeah, look what they did. They changed that plus to a minus. Don't confuse yourself. You know why that is. They switched the limits, guys. Maybe put that under your one of your resources or one of your things to do. If you find it hard, maybe switch these things. Put a minus on the outside. Letter B, they did it exactly how. Oh, well, kind of. They they actually integrated the number 2. I find that funny. Look, here it is. They integrated from 1 to 3. They integrated 2. I wouldn't do that. If you want to, go ahead. I went ahead and just used geometry on that part. Here it is, 2/3, x minus 4 to the 3rd power. Perfect. We got the 10. Oh, that's funny. I can't believe. I guess that was the most common thing that kids did. They integrated the number 2 there. 3 points there. Letter C, the graph of f is increasing in concave up between 0 and 1 and 4 to 6 because f prime. Oh, I wish I would have done that. I think we got full credit. But I think it would have been nice if we say f prime equals g. We got the full credit though. Because f prime, which equals g, is positive there, and f prime equals g is increasing on those intervals. Okay, fair enough. They said what we said. But I think it would have been nice if we would have connected it. So put that in your notes, connect f prime to g. And then the graph of f has a point of inflection at x equals 4 because f prime, which equals g, changes from decreasing to increasing at x equals 4. I like it, guys. All right, let's all come back.